This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club's seminar series. This is session number 120. Hope your fall season is off to a good start. The title of today's presentation is RGB Usage at the NWS Ocean Prediction Center, presented by Michael Folmer, the Warning Coordination Meteorologist there at the Ocean Prediction Center. Glad to have our discussion following the presentation facilitated by Brian Curran, the Science and Operations Officer at the Midland, Texas Weather Forecast Office. As you just heard, this session is being recorded. There will be an opportunity for Q&A after the presentation, and during that Q&A, we particularly encourage attendees from our forecast offices and regional headquarters, national centers, to post their questions in the chat, and we will field them that way. Also, if you have a longer question and wish to elaborate, you can indicate so in the chat and unmute at the appropriate time. We encourage attendees to sign in with your full name, or if you have not done that and using an office account, please specify your full name when asking a question in the chat. Also, we've been told that some of our TowerS communications have been ending up in the spam folder. We're sorry to hear that, but please check your spam folder, as the email system may occasionally reroute those notifications there. I know that sometimes I see things in spam that are from people that I don't normally communicate with. So if somebody's communicating with you for the first time, unfortunately with those NOAA.gov accounts, it ends up in the spam folder. So good to keep an eye on that intermittently. We're always looking for future presenters for the Satellite Book Club, and if you're interested in sharing an application with your colleagues, please contact the TowerS team. And if you're looking for training materials, Brian Mata at the Office of the Chief Learning Officer can help point you to training materials or possibly create training materials that may be unavailable, satellite or otherwise. I'd like to thank our TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, that goes on JPSS programs, for their support of the Satellite Book Club, and of course our facilitator, presenter, and all of you for being with us today. Without further ado, I'd like to introduce Dr. Michael Folmer, who's a new Warning Coordination Meteorologist for the Ocean Prediction Center in College Park, Maryland, and has been a meteorologist at OPC for about 4 years. Prior to these roles, he was the Satellite Liaison at OPC, the Weather Prediction Center, and the National Hurricane Center Tropical Analysis and Forecast Branch. Although he has a tropical meteorology background, satellite and mid-latitude weather have become his main focus. Michael, welcome to the Satellite Book Club today.
All right, thank you very much, Jordan. I hope everyone can hear me well out there. Today's presentation was given a couple weeks ago at an RGB workshop for WMO and at CIRA. So there might be some repeat for some on here, but new for others. And the goal of this presentation is just give you a little bit of insight into how the Ocean Prediction Center is utilizing satellite in the surface analysis as well as the forecast and warning process at OPC. So without how busy can it actually get at the Ocean Prediction Center? This was from a couple weeks ago when I was actually at the conference. And as you can see here with the map that was produced by one of our forecasters, Casey, you can see a hurricane force in the Gulf of Alaska. You see a storm force, and hopefully you can see my pointer here near Kamchatka. You have pretty long fronts. You have a tropical cyclone. It can get pretty dicey in the fall and early winter as you're mixing the seasons across some of our basins, but we cover everything north of about 30 degrees north up into the Arctic. So how have RGBs been incorporated into OPC operations? As I mentioned here, a few different ways we use the RGBs. It's not to replace single channel usage at all. But more for enhancing certain features that might be a little harder to diagnose or not as quick to diagnose. So surface analysis, we utilize air mass geocolor, nighttime microphysics, storm force and hurricane force. Air mass is used quite often, extratropical, tropical transitions. even incorporate some differential water vapor, fog analysis, the nighttime microphysics, day snow fog, marine convection. We use some of the convective products, even though some of them have a little better signal over land. We have found some use. And then dust diagnostics, which isn't used as much at OPC, more at the National Hurricane Center. We have the dust and Saharan air split layer, as well as natural color and geocolor. So I'm going to give you a little bit of 101 on how we put some of our surface analyses together. This portion will be relatively fast, so I apologize, but feel free to look at the slides later. Typically, we'll start off, in this case, we have a bit of a spaghetti plot of our favored models for the day. And we'll start at least putting down our surface low and surface high locations as a first guess based on the initialization of the model run. And then we'll throw in some what we call marine fronts, but this is a way of looking at moisture convergence as well as winds in the lower layers. In particular, 1,000 to 850 millibar thickness winds up being pretty useful. And then we start to look at how things are materializing in the satellite imagery. So in this case, I'm showing the air mass RGB, and if I'm the forecaster for this particular map, I'm looking at some of the features, particularly in the water vapor channels. And this is actually, I will ask a couple questions. I just want to keep everyone on their toes. And if you could put it in the chat, maybe Brian can help me as far as giving some answers that are put out there. But does anyone out there know, when you're looking at the air mass RGB in particular, what two water vapor channels are used in order to get the reddish coloring and some of the bluish coloring that you see in this image? I can wait just a quick second or two if anyone wants to put it in the chat. Do we have any guesses yet, Brian?
No, we don't. Well, actually, Steve Mueller says 6.2 and 7.3.
All right, I think he's cheating, but yes, he is actually correct. 6.2 minus 7.3 really helps to enhance the area of drying within the layer between those two weighting functions. Typically, we're looking in the 600 millibar up to about 300-ish millibars, but in very dry areas, you can get down to 700. So this is a great way for us to utilize some of the water vapor attributes as well as the infrared attributes to see where thunderstorm development is in the baroclinic zones, as well as where surface and mid-level features exist. From there, we may move on to visible imagery. In this case, I have the geocolor imagery produced by Steve Miller and Sierra. And again, try to match up. I've now underlaid the satellite imagery with my surface lows and surface highs. And again, another view, this one, the 0.86, which tends to work quite well over ocean, creating the darker background at that weighting function for looking at some of the fine-tuned features. Of course, this is only daytime that we can utilize this, but winds up being a pretty helpful. And then here's the observations that may be available to us. As you can see here, not a lot to pick and choose from. I would dare say just call it slim pickings for what it is, especially Central Pacific. Very few observations are available to us. It's whatever ship might be producing an observation at that time, or buoys that might be floating or stationary. So we have to rely a lot around the periphery, but it winds up becoming a coin toss in a lot of these situations. So again, we'll go back. I now have the METARs in this particular case overlaid with the satellite imagery. ASCAT winds up being a very helpful tool. We just have to keep in mind when the ASCAT passes occur, and you can see some of the times in here. So this particular analysis is a 0Z analysis. A lot of these ASCAT images are old, but if my low, for instance, this 1012 low in the middle of the map here, looks to be lagging, and this is an older image, then I start to adjust forward based on that. You may also notice that my low placement, and I'm putting myself on the chopping block here, was way off compared to where ASCAT was seeing the winds, and also see an additional low back here in the baroclinic zone. So ASCAT is a very helpful tool. Again, we'll go back to satellite imagery, and then we'll underlay some of the other features to actually put our fronts together. In this case, 925 temperature advection relative vorticity, and then back to the marine fronts. And that's more or less, I'm giving you the very Reader's Digest version of how surface analysis gets put together. And this map then becomes what you saw in the first image. But then we get to the warning side of things. So not only do we produce the surface map, then we need to actually put the warnings that are out there. And I call this a surprise gale more because some of these polar lows that develop near Siberia, we sometimes see them in the Davis Straits near Greenland. They tend to not be captured very well by our suite of models. And you can only get mesoscale models so far into our basin. So we tend to use a lot of these synoptic scale models like the GFS European, UK Met, Canadian, so on and so forth. So in this case, you see that we have an area based on the color bar on the top of 25 to 30 knot winds up near the Siberian coast here, pretty large gales over the open ocean, and a slow in the Sea of Akash that is moving towards the Kamchatka Peninsula. And I zoom in a little bit here, relatively small system with the 30 knot winds on the southwest quadrant, more what I would expect with a polar low. And at the time of the surface analysis and available winds and no model guidance to indicate otherwise, you can see the forecaster placed the surface lows right here near the coast. But then we get an opportunistic ASCAT pass, and lo and behold, you have gales. And the gales are right near where that ice edge is. And it could be one reason why models tend to miss those. Zooming in again, not only that, the gale in this case is in the cold conveyor belt portion of the polar low and squeezed right up against the coast and the ice sheet. So what you can see here is, in this case, the air mass imagery and some of the water vapor attributes we would typically use would not be as helpful. There was some discussion about how limb correcting that is provided by NASA Sport might assist in some of these in the future. But in this case, it would have been very challenging because the area we look for, in the area I'm circling here near that 2311 timestamp, is typically what we would look for the gale force winds to be located. So I had to, this is my forecast map, I had to quickly adjust for this polar low with an occluded front and the gale, as you can see, just to the south of the ice sheet to the north here. Here's just a longer animation. I'll let it run once. I highly encourage you, if you have a chance after this presentation, to look at it. I can make it available to whoever, but here are the two polar lows that are moving along the Siberian coast, kind of stretched out, and the larger synoptic scale lows with much more of the jet energy to the south. So this is kind of like an Arctic branch type featuring that break off of Kamchatka and the lee side cyclogenesis, but tends to be a pretty big challenge for us. Here we have another one, and this is another case where model guidance was not as strong with this particular system here as it was approaching British Columbia, while the models were all over this much bigger system, which became a powerful 70 knot plus hurricane force low. But this first low, a lot of the model guidance was giving us 40 to 45 knot winds, and based on the imagery, and we didn't have ASCAT yet, we went with a storm force upgrade. And here are the surface maps overlaid on the air mass RGB just to show we had a storm force in the Bering Sea, pretty complex gale over the Western Pacific. Here is the storm force winds, which match up quite well with a lot of this reddish coloring you're seeing in the air mass RGB. And here's our storm force low as it's approaching British Columbia with the storm warning label indicated. And we happened right after the forecast was being issued and the surface map was getting ready to be sent to get an ideal ASCAT pass, which shows storm force winds of 50 to 55 knots right in that bent back front portion of the low where we would typically look for such things. So it's a case where the imagery and then ASCAT actually beat out the models. The models were a bit slow in occluding this system and then strengthening it accordingly. The final case I have for air mass RGB usage when we're looking at it for warnings, this is a situation where the Ocean Prediction Center is issuing the initial advisories for an extratropical low that undergoes a subtropical to tropical transition and then back to just a remnant low to the south of the Azores. These are the Azore Islands out here. So this is pretty much in the center of the Atlantic Ocean. And in this case, the air mass RGB is very helpful in seeing the transition occur as you start to lose a lot of the deeper reds of the water vapor contributions, and you start to see much more of the green, which is a much more moist environment, warmer environment, more typical of what you would expect for a tropical cyclone to form, or a subtropical cyclone. But then as you can see, this other water vapor feature, this upper low, which becomes more of like a tropical upper tropospheric trough, then interacts with the remnant circulation. My last question I was going to ask everyone is, do you know which storm is rotating around Joyce in this case? And you'd have to know your 2018 hurricane season best tracks probably to get this, but I'll throw that out there and see if anyone wants to take a stab on the chat really quick. And don't be shy. Any guesses yet? I'm not seeing anything.
No, we're not getting any guesses yet, and I'm as clueless as the next one. So,
all right, so here's Joyce, and here is another system. For the sake of time, this is Helene. So Helene had formed and was well south over the tropical Eastern Atlantic, and between the H and the J storm and I storm had formed farther to the west. So you actually saw what was almost a Fujiwara-like impact here, and I think this imagery in particular is really good at showing some of those upper level features and the mid to low level features interacting, as Helene actually gets tossed around to the east of Joyce, and then Joyce follows in the trough of Helene, but then gets left behind like a little orphan, unfortunately, as it wanders over the Atlantic. The final imagery here is just showing you how we use the nighttime microphysics. We tend to find that models don't really handle fog very well near Georges Bank, which is in this general location southeast of New England. But what's really nice about this is you can actually see in the darker colors underlaid, these are oceanic features. Whoops, sorry about that, everyone. And in this darker coloring, that's actually warm water. And notice as the Gulf Stream, in this case, this is the north wall here, and you have some of the cooler waters to the north. It's June, so you still have some remnants of the Labrador Current. You get little eddies that spin off. What's really fascinating about this imagery, though, is over the relatively warmer water, you're getting a signal where you have less translucent, much more opaque cloud, which we've learned through looking at this. I probably have learned more because I've been staring at this for about 11 years. But the imagery here showing more stratus cloud, while just to the north over the cooler waters, again, approaching the Georges Bank area, you see this much more translucent or transparent type of cloud. That is actually sea fog. And you can see some of it even in the very light northerly flow extending up towards where you kind of get a mixed cloud up here south of Nova Scotia. But this imagery has proven to be very, very useful when we are trying to assess where our fog is located, along with our guidance. So with that, I come to the end of my presentation here, and I try to stay very close to my time limit. This is just a very fast 3-month loop just to show you how stormy the Atlantic is. I spent a lot of time in the Pacific, so I want to give the Atlantic its due process here. And so enjoy the animation, and I would be happy as we go into discussion to take any questions. So thank you very much.
thank you, Michael, for your excellent presentation. I encourage you all to stay on for the discussion, and if you're at a field office or regional HQ, Please specify your full name in the chat when asking a question. Also, if you don't mind, complete the feedback survey posted in the chat room. Now, a week from today, on Thursday, November 10th at 12 p.m. ET, that would be 18Z, I guess, with the time change. Bill Line, physical scientist from the Regional and Mesoscale Meteorology Branch at NESDIS Star 17Z, I'm sorry, will discuss applications of satellite imagery during winter weather scenarios. That sounds like that would be a great presentation to have as we come up into the cold season for us. I also encourage you all to contact the Tower S team, specifically Lee Byerly and Kashad Bowman, for questions about the SBC or for configurations of satellite products. Now, with that, I guess we could start with some questions here, if you're willing, Michael.
Yes, and I believe I was going to ask the first question to the audience.
Okay.
So my question, after having conversations with some of the national centers about a day ago, we were talking about different RGB usage compared to what is typically used from the single channels. And I'd be curious, especially to hear from the forecasters out in the field that might be on this this call. What RGBs do you find useful at your office? You can feel free to put that in the chat or I guess however you want to handle that, Brian. But
Okay.
It's been really eye-opening to hear what is used and the differences even amongst just the national centers and what is deemed as useful for operations. So I open that up.
I can tell you what we use in Midland, and some other plains offices might come up. We found that the Deborah dust product is extremely useful in picking out dust and also messaging to our partners and customers the potential for lowered visibilities and dust, and that extends everywhere from the general public to aviation. Brian Caffrey says the the nighttime micro and air mass RGB used often in Southeast Alaska.
That makes a lot of sense, especially where borders are boundaries.
Sure. Anyone else have any RGBs that they'd be willing to share? Ryan Walburn says nighttime microphysics for fog and true color for Bay Area coastal waters. And Eric Platt has nighttime microphysics for fog and low cloud development in South Central Texas.
All right. I know we have a few OPC forecasters on, so if there's any that I didn't mention that you find useful, feel free to throw that in there. Yeah, day cloud phase distinction.
Yeah,
full line.
That's also important.
That's one I think we're still learning on our end.
Aaron Jacobs at Juneau says that they use the day cloud phase, and now the new one for freezing spray using VIIRS and ABI.
I think that would be very useful for our products since we do freezing spray warnings at OPC. That's something I learned about a couple weeks ago that I'd be interested in us looking at.
Awesome. Anyone else? Okay, we'll proceed to the questions that have been asked in chat so far. Ryan Walburn at Monterey asks the question that they bring in some Himawari data to help with our backup operations of Hawaii and for our CWSU international forecasting. He's curious how you guys are ingesting all of those Himawari files. Is that a NAWIPS thing?
So right now, again, this was on a phone call we actually had yesterday to discuss. We had Himawari in our AWIPS I believe it had to be taken out due to a bit of an overload issue or some issues that were affecting operations. We largely use the Himawari versions of all these products in our NAWIPS, which is utilizing GEMPACK. So it's area files from Macitus that are then ingested. We do pull in a lot of satellite data. And when I was a liaison in particular, I'm sure I got lots of groans because I wanted our forecasters to have everything we could possibly have since we cover so much ocean. So we'll use Mediasat, both of the GOES birds, as well as Himawari, and what about 12 to 17 RGBs per geostationary on top of these single channels. So yeah, it's a lot. It's an absolute lot.
Steve Goodman has a question. He says, Michael, given the OPC aerial overlap with NHC and TAFB, for example, do you coordinate with them at all in identifying significant features and hazards?
We actually have, and we'll even do that with Alaska. We had great coordination with, some of you may remember, Typhoon, I believe it was Super Typhoon at one point, Merbach, as it went into the Bering Sea. We coordinated quite a bit on features, surface analysis, warnings. When it comes to TAFB and HFO, usually when there's systems, whether they be tropical or even non-tropical, we're going into our cool season now, and the tropics eventually may decide to slow down, who knows. We will coordinate on systems that cross 31 degrees north in the Atlantic and 30 degrees in the Pacific, just a slight difference in the latitude. But yeah, I've personally made calls to both centers to discuss these different features.
I apologize, Mike. Mike, if I butcher your name, Mike Jamalkowski asks, he says, incredible capabilities, we've come so far. I would have given a limb for these tools when I was a young Air Force forecaster on Shemya Island in the Aleutians in the 70s. You're dating yourself, Mike.
I also like the use of limb as a double entendre there. That was pretty good.
Yeah, yeah. Timothy Smith comments that when you all get on AWIPS, do you have plans to look at how derived or level 2 products might supplement RGBs? Examples might be how TPW or total precipitable water varies for a given air mass color, AOD to verify the pink color, or dust RGB is dust, cloud phase product to verify cloud phase, etc.
The answer is absolutely yes. We do have those products available in AWIPS, many of them, if not all of them. The problem has been being able to overlay our product generation. Usually when we have to pull products up like that, we have to look back and forth between screens and try to eye matching them up. I foresee it being much more utilized and definitely overlaying various products with ancillary data that we are kind of limited with in NAWIPS. You can only overlay so many things. You can't overlay radar, for instance, with satellite. Not that we use radar a lot, we're over open ocean, but near the coastal areas, that would be a beneficial addition, for instance. So I do think as we eventually, on that magical day, go into our AWIPS environment for all product generation, that you'll see a lot more of that.
Cool. Brian Mata asked the question here. He says, hi, Michael. I liked what you had to say about the value of satellite observations in data sparse regions. Can you elaborate more on the value and or significance to the POC surface map regions in regards to positioning pressure centers, frontal positions, and other significant weather boundaries? If the models or previous analyses miss a feature, how does OPC communicate that in discussions of products?
Well, it does happen pretty often. You get a lot of strange trough formations, and sometimes even with our larger synoptic scale troughs. You know, if you have a very large ocean storm in either basin, you'll get a lot of forming fronts behind the initial baroclinic zone, the initial fronts. And the best way to communicate that, you know, especially in some of those surprise situations, I don't think I'm speaking out of turn with my colleagues who are on this call today, that there have been many times where we will be surprised by something because we had no data and no model support. So typically we can not only add it to the map, but if it's in our high seas area, we wind up adding it to our high seas forecast, which is a text product at this moment. Eventually we will go full basin grids, and that'll be another way we can communicate some of those challenges that come up. But yeah, the lack of observations, and we are a very, very heavy satellite center, probably one of the heaviest of all the national centers. So when you don't have the surface obs and you don't have ships, I mean, put it to you this way, I don't know many ship captains that want to be in a storm or hurricane force wind event. So as much as we appreciate getting observations in those rare occurrences, we also scratch our heads and say, why are you there? So we may appreciate it, but we have to use everything at our disposal. ASCAT, in the end, along with some of these satellite products that I demonstrated today, winds up being the best combination so far. And we are starting to get into SARSAT and some other techniques to get more coverage of ocean winds.
Oh, that's a good segue into our next question from Curtis Seaman at Sarah CSU. Are you planning to receive Meteosat 3rd generation?
Absolutely, we need it for our operations. There's no way we could do our job without it. Even though we get a lot of extension, as you can see in this animation, using GOES East, we do analysis over much of Europe. So we definitely need 3rd generation. And it also help with features that may be on the limbs that wind up not being addressed as well by GOES East.
Okay, Timothy Schmidt asks, as you know, the local AWIP satellite menus underlay the derived products, so one can access via the readout option while still viewing the RGBs. I think that's more of a comment than a question.
Yes.
But that is interesting to know. I didn't know that. Bill, I'm sorry if I butcher your name. Bill Schoberg may have already asked this already, but I don't think we have. What's the status of AWIPs at the centers?
I would say the best way to answer this question, I love getting it, as I'm sure you can probably see by my face, is we are more in a hybrid type of situation where some of our products have migrated over to the AWIPs, especially the GFE side of AWIPs. So in that case, we can do grids in our offshore zones, for instance, using AWIPs. The majority of our prognostic maps, though, you know, we do a 24, 48, 72, 96 hour forecasts. The 72, 96 are only 12Z. The 48 hours are 0 and 12Z. And the 24 hours as well, sorry, is also 0 and 12Z. Those are all generated in NAWIPs, and our surface analysis at all the centers up to this moment is still heavily used or heavily created in the NAWIPs environment. In order to move that over, it's going to require, I think, a lot of coordination, if I'm understanding things, amongst OPC, WPC, and the Hurricane Center, TAFB in particular, as well as HFO. We'd all have to pretty much migrate at the same time. It's a very robust product that we produce that covers a tremendous amount of real estate.
Cool. Thank you for commenting on that. Brian Mata has another question. He asks, does OPC use new caps or gridded new caps?
We've introduced in the past, at the tail end of my liaison days, we were just starting to get into that. I know many forecasters have brought the new caps into the forecast process when it's available. Sometimes it's not available in AWIPS, but I can mainly speak for myself here. I like some of the ozone products that are produced by new caps, and it is also helpful to look at some of the SKU-T, and I'm really interested in getting much more of the planner type products that could show us moisture and temperature profiles so that we can match it up with things like air mass or even just single channel. But to get a better assessment of the environment that might be producing the warning category winds, the environment that is producing the thunderstorms over the Gulf Stream, for instance. So I think new caps is something that's going to be used more heavily moving forward than it has been up to this point. But yes, Bill, it's absolutely a very useful product. We like it.
John Forsyth says, great talk. How do ships at sea receive forecasts and warnings? From OPC directly or third-party sources which use OPC guidance?
Well, we do have a website, which would be the more direct way, but a lot of our transmission goes through and is coordinated with the U.S. Coast Guard.
Okay.
So they'll still get radio facts. There are some satellite distributions. You have something called ECDIS. There could be a whole talk just on how mariners are receiving some of our products, but there's multiple distribution sources. We're still surprised how much radio fax is used, believe it or not, since that's definitely an older generation type of transmission.
Sure. Brian Mata has another question. He asks, does OPC have a set of criteria for calling MDSs? I'm not sure what an MDS is.
That's the mesoscale window.
Okay.
1 minute, or if you overlay the 30-second imagery. We're pretty low on the list. Not making that a complaint per se, but we have gotten some mesoscale domains, especially with systems that form along the Gulf Stream in the winter. We tend to get very strange phenomena along that Gulf Stream with a coastal front, a lot of high theta E air being lifted over a coastal front that then tries to back towards the coast. Those mesoscale windows are very, very helpful in seeing how that materializes as a surface low forms. And we've seen that a few times in the past couple of years, where you'll actually get almost a supercell driven mesolow that then becomes the surface low. And in a lot of those cases, models can be jumpy. They can be all over the place. So yeah, the 1 minute and 30-second imagery can be very, very helpful in those high impact cases, because guess where a lot of mariners are? They're going to be right in that general location.
Sure.
So it's a high impact zone.
Got a few more questions here. Mike Jamokowski asks, he says he's looking forward to the GeoXO era, as am I. What kinds of improvements do you favor for OPC with imaging and perhaps a hyperspectral ocean color instrument?
We are not opposed to more satellite data. So we're going to be very happy with what comes out in the GeoXO time. Of course, we would love to have a geostationary scatterometer. That's not going to happen. A geostationary microwave, that's not going to happen. But some of the additional usages, for instance, because of latency issues, we tend to underutilize the day-night band on VIIRS because or on JPSS 1, because I guess it's NOAA 20 now, sorry. I'm still back in the old days here. Because of the latency, we could more or less look at it after the fact. Getting something like that on a geostationary would be a huge deal for doing nighttime analysis, especially over very data sparse areas. But in general, higher resolution and the temporal scales that we currently have are great. So any improvements, we're gonna eat up. I don't know if that's a great way to answer the question, but I'm excited, I guess is what I'm trying to say.
Well, it looks like we've got one more question and one more comment here. Scott Lindstrom asks, to piggyback on the ocean color question, does OPC do much with algal blooms or red tides or other oceanic water quality issues?
That's not in our purview. That's not something we directly deal with, but we do coordinate with ocean services on some products occasionally, especially more on the application side of the house with products, things like that. But in the forecast branch, we don't directly deal with algal blooms or coral bleaching or any of those things.
Okay. And the last question is from Javier Villegas Bravo. He says he's been trying to reintroduce new caps to OPC and WPC, but there is a very limited window in a shift to look at it, and it has a 1.5 hour latency in a polar pass. He says he's looking forward to the MTG sounder and GeoXO sounder to move the sounders beyond data assimilation. I'm
with Javier on that one.
Yeah, I would be too.
Yeah.
Okay, we're coming up close to the end here. Thank you all for your insightful questions and answers, Michael. I think we're at the end here. I can kick it back over to Jordan for some closing comments. Thank you again, Mike.
Thank you.
All right. Thank you so much, Brian, for that excellent job moderating. Really appreciate all the questions that came in from the audience. And again, thank you to Michael Folmer for that great presentation today. Our presentations in the Satellite Book Club don't stop. It's a weekly seminar series, and next week we are going to hear from Bill Line, as you heard about, as we head into the winter months. Bill's going to be talking about applications of satellite imagery during winter weather scenarios. You may know Bill currently is a physical scientist with NESDIS STAR, but previously was a forecaster at the NWS Pueblo office and also a fellow satellite liaison. So we're looking forward to having Bill next week. In the meantime, if you have any questions about the Satellite Book Club or the configuration of satellite products, please get in touch with Kushad Bowman. He can help with that. We also have our TowerS team members, John Evans and Lee Byerly, available as well. So don't hesitate to reach out if you have any questions about the book club or satellite product configuration. Our TowerS team is there to help you. With that, I think that'll wrap it up for this week. We are looking forward to hopefully the launch of JPSS 2 by this time next week. A slight little slip in the launch schedule, but we are headed toward a launch in the middle of next week. So thanks everybody for joining us today. Hope everything's going well, and you'll tune in again next week. Take care now.
Y'all be